Hi, welcome to Nomis Academy. In this video, we are going to be looking at the area common to two curves under the application of integration. Now let's consider the graph. Consider the graph. Okay, we call here the y-axis and we call here the x-axis. Alright, when we have a curve facing down this way, and then we also have another curve facing up. Okay, we can liken the two curves to be a parabola facing down and another parabola facing up. Now they intersect at a point and we can trace that to the x-axis. We can trace that to the x-axis. At this point we call here A and then we also call here B. Supposing we are asked to find the area bounded by these two curves. Supposing we are asked to find the area bounded by these two curves. So how do we go about that? The first thing we need to do is we need to know the area under the curve. The first curve, let's call this the curve facing up will be called f1 of x, and then the other one will be called f2 of x. Alright, so now to find the area facing down or the area below the curve f2 of x. So let's pick that separately. Remember we have something like this, the area of the curve facing down. So let's call that a1. And then we also have the area of the curve facing up. Have something like this. Okay, facing up. So we call this A2. So for us to now get the area, so this is the area of the curve facing down, while this is the area of the curve facing up. So for us to get the area bounded by the two curves, so that will be area is equal to first the area 1, that is the area of the curve facing down, minus area of the curve facing up. So this would be the right thing to do. And I hope you remember what A stands for. Remember we say that area is equal to integral from A to B f of x dx. So in this case here we have integral. Mind you, we have 2 points. Integral from A to B, f of, remember, f of f2 of x, the x, minus integral of from A to B, f1 of x. Okay, this is 2 and this is 1, the x. So when you do this, that will be the area bounded by the two curves. So now let's pick an example to buttress the idea I've given so far. Let's pick an example. Okay, so an example says that example 1, find the area of the region bounded by the curves y equal to x squared and y equal to minus x squared plus 4. Solution. So you agree with me that the first curve is the curve facing up. So this is the curve facing up, and then while this is the curve facing down. This is a parabola facing down, while this is the curve facing up. So what we need to do, we need to get the values of x or the vertical lines or the points where the curve intersects. So to do that, we need to get our x values. We are going to equate y to each other because we say y is equal to x squared. Here y is equal to minus x squared plus 4. So we can say that x squared is equal to minus x squared plus 4. So to find x, we move this to this side. So that will be x squared plus x squared equal to 4. So this gives us 2x squared equal to 4. So divide both sides by 2. X squared is equal to 2. So to find the value of x squared, take the square root of both sides. X squared is equal to plus or minus square root of 2. So these are the limiting values of x. So at the point, we are starting from the point where x is equal to minus root 2 to the point where x is equal to plus root 2. Alright, so now let's pick the formula and then solve. So let's just take a simple graph to get a clear picture of the area we are looking for. Let's take this to be the graph. So this is the parabola, this is y and this is x. This is the parabola facing up. So it is called y equal to x squared. And then the parabola facing down is called y equal to minus x squared plus 4. Okay, so we're going to trace down to the x-axis, So now we got this point. According to this, we got this point to be minus root 2. Why this point is root 2. Root 2. So this is the area we are looking for. The area bounded by the two curves. Alright, so you remember the formula? The formula says that area is equal to the first one. Let's pick the area of the first one. That's the area below the curve facing down. That will be integral from minus root 2 to root 2. And then we have minus x squared plus 4 dx minus, that's the formula, remember that, minus integral from minus root 2 to root 2, and then we have x squared dx. Okay, so we can actually bring everything together. Area is equal to integral of root 2 minus root 2 to root 2, and then we bring this together. That will be minus x squared plus 4 minus x squared, and then here we have the x. Okay, let's keep moving. Let me clean the question from here. Okay, so we have area is equal to integral from minus root 2 to root 2, then minus x squared minus x squared. That will give us minus 2x squared plus 4. So we are going to integrate this. So to integrate this, we'll have area is equal to integral from minus root 2 to root 2. So that will be what? Integrate minus 2x squared. That will give us minus 2x raised to the power of 3 all over. Okay, we don't need to write the integral again. No need to write since we are integrating. So minus 2x cubed all over 3. Okay, the next one plus 4x, and then the limits are minus root 2 to root 2. So the next thing to do is to slot in the values or the upper limit and the lower limit. So let's clean this side to give us the final solution to the problem. Okay, So area is equal to, let's slot in the limits. When x is root 2, we have minus 2 root 2 raised to the power of 3 all over 3 plus 4 root 2, okay, minus when x is minus root 2. So here we have minus 2 minus root 2 raised to the power of 3 all over 3 plus 4 minus root 2. Okay, so let's simplify that. We have a is equal to here root 2 raised to the power of 3. That will give us 2 root 2. So 2 multiplied by minus 2, we have minus 4 root 2 over 3 plus 4 root 2 minus, now here we also have minus root 2 raised to the power of 3. That will be minus 2 root 2. So minus 2 times minus 2 is 4. So we have 4 root 2 over 3 plus, okay, now we have minus 4 root 2. Okay, now the next a equal to, we can clear off the brackets, minus 4 root 2 all over 3 plus 4 root 2 minus 4 root 3 root 2 plus 4 root 2. So when we collect like thing, you see that this and this here will give us 2, which is minus 8 root 3 minus 8 over 3 root 2, and then we add up this together, that will give us plus 8 root 2. Okay, so when we add this up together, when we add them up together, we are going to get a is equal to minus 16 all over 3 root 2. Okay, so area cannot be a negative value, it must be a positive value. So we have absolute value, which will give us area to be 16 over 3 root 2 square units. So this is the final solution. So this is the area bounded by the two curves. The area bounded by the two curves. Thank you for watching. See you next time. Bye.